All right. Apologies for the delay, but we're gonna get started now. Welcome to week 4. As you can see, I have a bunch of goodies up here, up on the table. We're gonna do a really fun 3D printer demo for you today, along with kind of like highlighting the basics of 3D printing for the most part. Also, a lot of people are gone because of Calc 2, so if you're wondering why your friends might be missing, that's probably why. But yeah, let's just get started. Um, Again, I'm gonna just briefly go over the final project. I talked about it, or I've been talking about it over the past couple weeks, but all of you should kind of understand what these requirements are now. Basically, we're just gonna let you run free to create whatever you like, as long as it's not something we've done in class already. Again, you want to have at least 5 design features. So please use at least 5. Like if you're curious, like using more than one extrusion will count as more than one feature. So if you want to do like a couple extrusions and then like maybe one revolve or something like that, that works. As long as there's at least 5. And you'll probably realize fairly quickly that 5 is very low if you want to make something like mildly complex. So again, these requirements are pretty low, but we really encourage you to challenge yourself and try to make something that you've never made before. The last point is kind of important because you will have the option of printing your finals once you finish this course. So I need to be able to make them, and if you design something that I can't make, then I won't be able to make it for you. So I'm going to go over a lot of like how to design with manufacturing in mind today. So please keep that in mind when you're designing your final projects. Like for example, you're going to learn about bridging in a little bit, but I asked people not to do very long bridges, and then one time someone gave me a Golden Gate bridge. So they kind of took what I said and they did the opposite. So yeah, please don't do that. But yeah, we're just gonna get started into today's lecture. I'm gonna be talking a lot. We're not gonna be doing a ton of assignments, so today's mostly just kind of a learning day and just kind of understanding how to ground yourself in reality when you're designing stuff. Again, you've probably seen these pictures already. Some of the past finals, which are pretty cool. My door's unlocked. Okay, so today we're going to be talking about designing with manufacturing in mind. As you're probably aware, there's a bunch of different manufacturing processes that you can choose whenever you're making a part. We're mostly going to be going over 3D printing, but I'm going to talk a little bit about the other stuff as well. So a more traditional form of manufacturing is called subtractive manufacturing. And that's kind of what you think about when someone makes something, because they usually start out with some form of material, and then they cut away with it with some form of tool to eventually get your end product, right? So you see on the left, it starts out as this big block, and then it has this tool, and it chips away at it until you get a final product. And this could be in the form of like a saw or kind of a mill or some like kind of lathe operation. But yeah, that's kind of what subtractive manufacturing is. You're just taking stuff away, hence subtract. Here are a couple like subtractive manufacturing processes. So like some things that come to mind is like drilling a hole is subtractive, milling something out, turning, routing, and even grinding or sanding is considered subtractive. So like all of these are pretty cool. Usually people do a lot of metal and stuff like that with subtractive, which is pretty cool. But there's a bunch of other processes, or there are other processes as well. The main one that we're going to be talking about today is additive manufacturing. So a lot of you think about additive, or you hear the word additive manufacturing and you think 3D printing, which is true, but it isn't the only additive manufacturing process. But as an example here, you kind of start with no material, and then you use some form of process that deposits material until you have your final product. In this case, it kind of looks like a 3D printer. So yeah. The other big additive manufacturing process that you may not have thought of is injection molding. So injection molding is an additive manufacturing process because you have a mold and then you're forcing some kind of material into it and then it creates your product. So it's not subtractive, it's additive, which is kind of cool. At least I thought that was pretty cool. But then, yes, there's 3D printing for additive manufacturing. And we have one here today. So I'm just going to be talking mainly about 3D printing now because that's kind of what this course is about. So as you can see, there's a bunch of different applications for 3D printing, and these like applications are growing like every day. The additive manufacturing scene is growing very quickly, which I find to be very fun and interesting. A lot of people see 3D printing as a rapid prototyping tool because it doesn't require any tooling to create advanced geometry. And I'll explain what that means in a little bit. But yeah. You'll also see it in like automotive scenes a little bit. There's like some like supercar or hypercar. I think it's called like the C Zinger, and it uses like 3D printed aluminum and titanium parts for its suspension components and like the main body, which is really interesting. So as you can see, the technology is growing. It's not everywhere yet, but it's making its way into a lot of places. Of course, there's a bunch of different types of 3D printing. I'm just going to list off a couple today. There's SLS 3D printing, which is more industrial, just because of all the setup and, you know, logistics surrounding this kind of machine. They're very expensive, but they basically use a kind of powdered material, and then they have a very strong laser that melts the powder into a solid object, and then it puts more powder on top of it, and it shoots lasers more, and then it will grow your part. This process is really cool because it uses the unlasered powder as kind of a support material for the other stuff it's making. So you can create really advanced geometries without much of a problem. You'll see that like the 3D printer that we have up here will have some limitations. SLA 3D printing is a different kind of printing. It's resin based. So instead of using a powder, it uses a resin like an epoxy. And then that resin is activated when UV light shines on it. So there's basically like a UV screen at the bottom of the printer, and it'll shine a certain like geometry at a very precise amount of time to cure it partially, and then it'll move up and then do it again and again until you have your part. It's really cool. The one advantage of it is that no matter how many parts you have on the print bed, it will take the same amount of time because it just exposes a certain layer. So as long as the layer number stays consistent, the print time is going to be the same, which is a fun fact. But yeah. But then again, the main thing that we're going to be talking about today is FDM or FFF 3D printing. It's probably the one that you're most familiar with, just because you see them all over campus and stuff like that. They've become increasingly affordable for students like us, which allows us to create really cool things. So how does it work? So my analogy for 3D printing is it's kind of like a hot glue gun on steroids. So everyone's used a hot glue gun before, right? It has like a hot nozzle, and then you have like this glue stick, and then you press the trigger, and then it like extrudes out some glue. So 3D printers are basically the same thing, but they take that hot glue gun and they usually melt some kind of plastic, and then they put it on a robot. So in this case, we have it on a 3-axis gantry, so it moves in X, Y, and Z, and then it creates your part for you. So how it works is it will print layer by layer. So it'll take your model and it'll cut it up into very small vertical sections, and then it'll draw like the outline and fill in the center of your model before going up and then doing it again, sometimes like hundreds of times. So you can see 3D printing in this way has a bunch of layers, which can be a form of failure, but we'll talk about that later. But basically, you'll see. Oh wait, I can start. Basically, 3D printers usually use some kind of filament. So this is a spool of PPG. You can see it's like 1.75 millimeters in diameter. You can pass this around. And it'll just extrude that through a nozzle. For me, it's 0.4 millimeters. And it'll do it very precisely to create your object. So now we're going to start going over different settings that you can apply when you're 3D printing stuff. So if you guys have ever used like a normal paper printer, you can see you probably like come across like a couple of settings that you can change. Like you can change things like DPI and the scale and stuff like that. But because we're working in 3 dimensions, there's a lot more variables that come into play. So the first and one of the more important ones would be the layer height. So it's basically how tall the layers are. I mean, that's kind of in the name. But you see these blue lines here, they're all like slightly higher than the other. So your changing your layer height will change how tall these are. And it can affect like your resolution. So if you're printing a really fine detailed model and you've printed at a really high layer height, you'll be losing some of that detail. But then if you print at a really low layer height, you'll be getting that detail back. And you'll see that changing any of these settings will kind of have like pros and cons to everything, right? So in this case, if you increase the layer height by making it taller, you're going to reduce your print time because your printer has to like draw less lines. If that makes sense. But you know, you're going to get some like reduced resolution. Sometimes if like surface finish is like a concern for you, if you use a really high layer height, you can kind of feel the layer lines, and that may not be desirable for you. So again, a lot of these settings are dependent on the model you're printing, and it's just good to keep these things in mind. Perimeters are also very important. It's basically how thick the wall is on the outside of your print. So if you didn't know, most prints that you get off a 3D printer are not completely solid. They're actually partially hollow. I have models. So you can see these models. I like saw them early, but you can see that they're not completely solid models. So changing the number of perimeters will change how thick the wall is on the outside. And generally, increasing the number of perimeters will make it stronger. But then again, you're adding more material and more lines for the printer to draw, so it's going to take longer. So again, something to keep in mind. The other part, like I said, prints are hollow, so they have an infill, and this density is something that you can change. So the parts that I'm passing around right now are printed at, I believe, 25% density, So you can see how increasing the density can generally lead to a stronger print, but it increases material cost and print time. Generally, I like to add more perimeters before I add more infill to make a part stronger, mostly because um, most of the strength you're going to need is closer to the outside and it's less important on the inside. Um, Supports are something that we use whenever we have a geometry that we can't really print because printers are limited by the laws of physics and gravity. And if you try to print in midair, things will start to droop, right? So to combat this, what we can do is we can add a sacrificial material that we call supports. I didn't bring any today, unfortunately. But supports can be used to support these overhangs. We like to call them overhangs. You can see on this print right here, this cylinder kind of sticks out the side, and that's kind of something that you can't really print easily. So if you use supports, you can kind of hold it up as you print it, and then you can take the supports off once it finishes. Again, when you use supports, you're adding more material and print time, but something to keep in mind is that you're also adding post-processing time. So if you're making one part, it may not matter, but if you're making like 100 parts and you're using supports for everything, that just means you're going to waste a lot of material and a lot of time cleaning up the part when a lot of the times, if you designed it correctly, you can just take it off the print bed and use it. So because you're all designers now, you have the power to design out the supports, which is something I really encourage you to do. Obviously, there's some scenarios where you're going to need supports, but because you're in charge of making the design, you can make your model easier to print. So we're going to talk a little bit about that later as well. But yeah, here's another example of supports. You can see like the H and the T kind of have really large overhangs. If you think about it, it's a 90-degree overhang because it's just horizontal. And sometimes you can't really print those. So you'll use supports to make them look nice. But yeah, with that, I'm just gonna jump into it. You guys can download the slicer and then we're just gonna slice apart for you. So in the Discord, if you go to resources, there's this link right here. We're gonna download some more software. Um, it'll take you to this website. And then you just want to click on drivers and apps and then download the slicer. Um, yeah, while you guys do that, does anybody have a suggestion on what I should print today? Because I'm doing a demo, so I want to choose a model and I don't know what to choose. So you can shout something out. School appropriate. Maybe something a little bit smaller and less intricate because I don't have like 7 a smaller transformer. All right. So this is also a good learning place. Just like the repositories online that we've had for the Lego bricks and stuff like that, there's a bunch of repositories online with models that people have already made. So I know some people were talking about STLs today, and STLs was kind of the standard for a lot of these 3D printed models. Um, so if you're wondering why STLs exist, that's partially why you'll see them floating around a lot. So this website is Thingiverse. You can use it to find a bunch of different models. As you can see, there's a bunch here already. These look like they're going to take a little bit too long, so I don't know. Okay, does anyone else have a suggestion? Because I want to print something a little bit smaller, because printing can take time. What's up? Oh, I don't know. Like you can ask like a dog or something. It's nothing like major. Tennis racket. Ooh, that might be a bit difficult. We'll see. Okay, yeah. Why don't we try this? Or maybe something that's more solid, because I like watching infill. You guys might like this, because this one has like no infill. Okay. If not, I'm just gonna pick for you. Low poly. Well, I was hoping that I would get like a solid model, and yeah, I don't know. Okay, we'll print this today. So, um, you also want to download this 3D Benchy, and you'll see it's an STL file, because that's what a lot of people use for their 3D printing projects. Um, the STL file is kind of being phased out in favor of the step file, because modern slicers can read step files now, which is really nice. So if you're ever exporting a file, I really recommend you choose a step over STL, because you guys have seen that working with STLs isn't as fun as a step, mostly because an STL is a surface. It's kind of like takes all the surfaces and creates a part, where a step file retains the original geometry. So you'll see the STLs have a bunch of triangles instead of curves, and that's just kind of how they're made. But step files retain all the curves and the geometry. So yeah, I recommend you using step files, but because this file is old, it's an STL. Um, who hasn't downloaded the slicer yet? All right, perfect. Okay, so when you launch it, it'll probably greet you with like a welcome screen. Um, so if anyone needs any help with the downloading process, just raise your hand. Okay. Yeah. This one's usually a lot faster than Fusion. Um, okay, so you'll usually be greeted by this welcome screen, and then it'll ask you to choose a printer. Um, I'm like this, the grade is based on the time that the slicer outputs. So you want to make sure that you're using the correct printer for this assignment. Okay, if you canceled out, you can go on this printer tab on the side, click add or remove printers, and then add or remove presets. Uh, and then it should boot up again. So the printer you want to choose is the Prusa Mini. So if you scroll down, there's this little cute printer right here. You want to make sure you choose this Prusa Mini right here. Don't choose the one that says Input Shaper. And then you want to choose 0.4 millimeter nozzle. So again, all the slicing times are different between printers because some printers can go faster than others. Um, so please choose this one. Um, so yeah, again, 0.4. And then once you click it, just press finish. To find your printer, because sometimes you might have more than one. I have like a bunch over here, but yours should just be Original, Prusa Mini, and Mini Plus. So you can click that one, and then your print bed should look like this. So like Fusion, you have like a workspace where you prepare your parts for printing, and in this case, it renders a virtual build plate at which you build stuff on. So let's just get a model on here real quick. You can do Control I, or I think File, Import, and then Import again. You want to find your model, and then it'll render your model before you want to slice it. So you can see if we zoom in, this is nice and smooth because we haven't sliced it yet. But before we slice it, we want to make sure that we have all our settings down. So I'm going to be changing a lot of settings and just running you through the UI. In this print, you don't really need supports, but I'm going to add them just so you know where they are. So these settings might look weird, but it's just to show you like where all the important settings are. So if we go back to the slide, I think it has, okay, yeah. So the slides have all the settings that we want to change. So over here, we're in Prusa Slicer, which is the software that we're using. We're using the Prusa Mini, so we've already selected the correct printer, hopefully. Right here, we want to change the number of perimeters. So if you want to view all your print settings, there's a tab up here in the top left that calls for print settings. Yours will probably look like this, but when you get more advanced in 3D printing and you want more options, you can like click this expert button and you can see you'll have a bunch of other options if you so desire. But for today, I'm just going to leave it at simple because we're just going to go over the basic parameters to change. So we're on the layers and perimeters tab. So right here, it tells you the number of perimeters that it's currently set to. It's set to 2 right now, but we want that to be 3. So I'm going to change that to 3. If we go back here, our resolution for this assignment is 0.15 millimeters on the speed setting. So up here, you can see there's a bunch of different presets. This is for your layer height, right? So it's your vertical resolution. So I'm under print settings on the top left. But right under it, you can see if you click on the drop down, there are a bunch of settings. And over here, I have some settings that I made for myself with some minor modifications. But yours should mostly be under system presets. So for today, we're going to choose the 0.15 millimeter speed one. So it's right here. It'll pop up this kind of warning because like we changed the preset already, right? So we changed it from 2 perimeters to 3 perimeters, and it's basically asking us if we want to transfer that to the 0.15 millimeter like profile. So in our case, we want to say yes. If you press discard, it'll delete it and put in whatever is the default for that profile, but then you can go back and change it. So I'm going to press transfer. You can see it retains the 3 perimeter count. Over here, we want to change the infill percentage. So there's a couple ways you can do that. There's infill on this tab next to layers and perimeters. And then you can change the density right here. So this assignment calls for a 20% infill, so we can change this to 20%. If you're curious, the other way to change it easily is going back to the platter and then just changing this infill on this tab here. So if that's more convenient for you, go for it. And then right here, supports are on. So right now, you can see there's no sacrificial material at all on this part, but I'm just going to add it. Normally when you print these, you don't, but I'm just going to show you where it is. So over here, I'm just going to set it to everywhere. and then it'll automatically like calculate where you should add supports. Again, for this model, you don't need to print it with supports, but I'm showing you that it's an option for when you might need it. So now that we have all our settings locked in, we can click slice now, and then it will slice the part. So your computer will do some thinking, and then it'll give you a preview of the sliced part. Raise your hand if you're having trouble with this. No one? Yeah, this looks kind of ugly, but it's okay. So your part should look like this. And you can see now, if I like zoom in really closely, you can start to see the layer lines, because this is a preview of the G code. And the G code is basically a really long list of movement commands for your printer to follow, so it creates your part. So over here, there's a slider. You can see that the part will grow as I like go up in the layer lines. And then over here, you can like see the movements it makes for each layer. So this is a really good visualization of what it does. So this arrow here is a representation of the nozzle, and you can see this is the first layer. It will like print all of this. The green is the supports, and this like yellow orange is the model. So that's the first layer, right? And then it'll continue, it'll go up a little bit, and then it'll make more lines, and eventually you'll have your finished product. Does that make sense? Again, the number of layers really depends, or really will impact your surface finish and print times. So if you were to increase this, you'll see that there are less layers that it prints, and it'll speed up the print time. So let's say you wanted to go back and change some of the settings. So I'm just going to do that. I'm going to change it to like 0.2 millimeters. I'm going to transfer all these settings. And then you can see the model disappears. And the reason why is every time you change something in your slicer, you have to reslice it because it has to recalculate all the movement paths. So if I slice it again, it'll remake my part, or it'll reslice my part. And you can see how the ending numbers might be totally different. So right here in normal mode, it tells you how long it's going to take, or at least an estimated amount of time. So it estimates like 2.5 hours. But if you were to change the layer height, you'll see that that time is probably a little bit different. I think if you had it at 0.15 speed, I think it was like almost 3 hours. I don't remember. Let's see. Yeah, so you can see like when you increase or like increase the resolution or like make the layer height smaller, the time will go up. And this is even using a speed profile. So in the other profile that I was using before is printing slower. And this one's moving faster, but it still takes longer because it just has more layers to print, and more layers means more time. Does all of this make sense to you? Yeah. Okay, cool. So again, these are a lot of settings to keep in mind when designing a part, because whatever you're making could really have like very different needs of another part, right? So if you look at some of these models that I brought today, a lot of them are printed with 25% infill and 4 perimeters. But then for the stuff that I really need to be super strong, I might change it to like 6 perimeters and like 100% infill. So like these are all like spring powered blasters. So the plungers and stuff like that are all 3D printed, and I print those at 100. But like the body and all the other parts are printed with less, so it makes it lighter and it takes less material and time. So again, it's a good example of, you know, utilizing these settings to get the fullest potential out of your parts. But yeah, okay, yes, this fun part. So I'm going to talk about 3D printing limitations, but before I start about rambling about the limitations, I'm going to start a print real quick. Um, so I actually use a different slicer than Prusa slicer now. So sorry if this doesn't make full sense to you. But the cool thing is a lot of these slicers, just like different CAD programs, have very similar, like maybe not user interfaces, but all of the settings are very similar. And that's partially because a lot of these slicers are based off of each other. So Prusa Slicer is an open source software, and then this random person decided that he wanted to add more features into it. So he's like, I'm going to create my own slicer. And then he created Orca Slicer. So you can see even the logos look very similar. And it's because he said that he used the base code from Prusa Slicer to create another slicer. So um, over here, this is Orca Slicer. You can see it looks a little bit different, but a lot of the settings are still the same, right? So over here, you have your layer height, you have your different printers, your filament. Oh yeah, I didn't talk about filament. If you ever are using different filaments in your slicer, make sure to change it over here. So depending on your material, it might have different like melting temperatures and like cooling settings that you might want to apply. So yeah, make sure you're using the right setting whenever you're slicing stuff. But yeah, so this is my printer. I like it because I can connect to my printer over Wi-Fi, which is pretty cool. A lot of new printers are doing that, so it's becoming more and more convenient. I like Orca Slicer because I can access my printer and control it from my laptop, which is cool. But again, it basically does the same thing. So as you can see, I'm going to be using Orca Slicer today, but you can kind of see how the workflow is the same. So we have this part right here. I'm going to make it a little bit smaller just so it takes a little bit less time. Maybe like 50%. And then I'm going to rotate it. So all these settings are very similar. So if I go back into Prusa Slicer, if I wanted to change the scale is right here. If I wanted to move it on the build plate, I can just drag it around. I can rotate it with the rotate command, and you can see I can spin it around. So you can see how they're different softwares, but they do the same thing. Again, if you want to go to your platter and manipulate stuff, there's two tabs over here. So right here is the preview with like the sliced profile. But if you want to move things, you have to click on this box. I forgot to mention that. My bad. But yeah, back in Orca Slicer, I'm using my Trident today. I'm printing in ASA, which is kind of like ABS, but it's UV resistant, which is kind of cool. So again, there's a slice button. It might be in a different place depending on your slicer, but it does the same thing. Again, I can view the different layers just like last time. It gives me like total time estimation. In this case, it's about 15 minutes. And then because mine's connected to my laptop, I can just tell it to print, which is nice. A lot of the times on like older printers, you'll need to use like a USB or a SD card to load it on. So a lot of times once you slice it, you just plug it in. A little button in the corner will pop up asking if you want to export it to your USB or SD card. You just put the file on there and then you run it. So I'm just going to tell it to go. It will send it to the printer. And then over here, this is the user interface for my printer. Again, your printer might be different if you have one. This is a little bit more complicated, but I'm running a firmware called Clipper on my printer. And then Clipper talks to this software called Mainsail, which displays all of this information. So this is a little bit like off topic for this class, but this is kind of like a UI of some printers. A lot of them aren't like this elaborate, but yeah. Over here, you can see the different temperatures. This one has a chamber thermistor because it likes, or ASA likes to print in a warm environment, so I'm keeping it enclosed. So yeah. I can nerd out about this stuff, but I won't. I'm just gonna start talking about limitations. It'll take a while to preheat because the bed has to heat up to 105 degrees Celsius, which is pretty warm, and the nozzle is about 270. But again, it depends on your material. So while it's preheating, I'm going to just go over some limitations for you to keep in mind when designing stuff for not only this final, but for everything else. Yeah. So the first thing I'm going to talk about is overhangs. So like I said earlier, you can't print things in midair. I wish you could because that would make my life a lot easier. But there's basically a threshold that you should avoid, so you don't have to use supports. So again, like in this image right here, you can see that this thing sticks out 90 degrees from like the horizontal or vertical surface. So that was what I consider a 90-degree overhang, right? So 90 degrees is quite a lot. You don't want that. So a good rule of thumb is to keep it at a nice 45-degree angle. This is convenient for you because when you are designing stuff, you can just add chamfers and stuff like that, and those are by default 45 degrees. So if you want something that sticks out or you want to kind of round a corner, I highly suggest you use a chamfer instead of a fillet, especially if it's in the vertical axis, right? So over here, you can see this overhang is very shallow. So this is only, I don't know, like 30 degrees. This one's probably hitting 45. But then as you see, as it goes farther in one direction, it'll start to droop. I actually have some models here. So, so if you see, I'm gonna hold it up, but this is like a temperature test, but it also a bridging and retraction and overhang test. So you can see over here, this print gets progressively like steep, if that makes sense. So it's printing harder and harder overhangs, and then it allows you to see like the limitations of your print. And once I pass this around, you'll see that as the overhang gets steeper, the print looks uglier and uglier. So I'm gonna pass this around. Um, so yeah, good rule of thumb, 45 degrees. And then most printers will be happy. My printer's cooling is like okay, so I can usually print a little bit more than 45. But again, 45 is a really safe number, especially if you plan on like posting your design for other people to print. You don't know how good their printer is, but most printers can do 45 degrees. The other thing, like vertical features. Oh yeah, okay. You want to just take a break and watch the printer for a little bit? Yeah. Feel free to get up and watch the printer. So basically, this printer is like pretty smart. So it does a lot of the stuff that we used to have to do manually automatically. So this has automatic training of the bed. So basically, you know how like 3 points make a it will probe 3 different points on the build plate, and then if it's out of skew, it will automatically back. Um, and then it has mesh bed leveling, so it'll probe multiple points on the print bed, and then it'll measure the slight deviation in height, and then it'll compensate that to get a nice print bed. A lot of this stuff is like really nerdy stuff, so if you're like going down this way. Um, it also has automatic Z calibration, which is really nice because it basically knows exactly where the nozzle is in relation to the bed. So again, you get more consistent first layers. The first layer is basically the most important layer for a 3D print because if the first layer isn't good and it fails, then everything else on top of it can fail. So yeah, this printer is pretty cool. This is like an open source project, so I didn't design this. This is like this was built by a bunch of people in collaboration who call themselves Boron. And this is their trident. As you can see, it's pretty dang fast, which I like. A lot of my old printers printed at like 80 millimeters a second, and the tool head would accelerate at like 800 to 1,000 millimeters per second slave. But this one was printing at like 300 millimeters per second and accelerating at 20,000 millimeters per second. So the tool head is pulling like 2Gs, which is kind of insane to me. But the cool thing is a lot of printers are becoming pretty fast like this. A lot of people like to compare this to the Bamboo Labs like X1 Carbon or P1P, and they're pretty comparable. I would say my friends who have Bamboos run about like 10 days off, which is already pretty fast. Um, but yeah, I like this because it's open source, so I can upgrade it. I'm getting a new tool head, so it's going to be a little bit faster. So hopefully in the end, I'll be getting like 40 gigs. But yeah, I'm kind of a 3D printer if you can't tell. So if you want to talk about it, you can, but I won't bore you too much. So yeah, let's get back to the vertical faces. So, like I was talking about overhangs, if you think about a vertical hole, they're also they also have slight overhangs. So if you think about a circle and drawing like a tangent line as you go up to the top of the circle, by the time you get to the top, it's a 90-degree overhang. And if you have a really large hole, it can start to droop. So if you see in this photo, the top of this hole doesn't look super nice, and it's because you're printing a large overhang and then it starts to droop. So there's a couple ways that you can combat this. One of my favorite ways of combating this is what I call like the teardrop method. So basically what you do is you take the hole and then you add a little teardrop on the top. So I draw 2 lines, I make them perpendicular to each other, and then I just make sure that the end point of the lines is like vertical to the center of the circle. Oops. So again, I'm talking like in like constraints now, right? So I set 2 lines like that are equal in length, and then I set them perpendicular to each other, and then I set the top of the point and the center of the circle to be vertical to each other. So those are 3 different constraints that I use, and then it fully constrains the line to the circle. So you'll see over here on the right, you'll see this teardrop, and the reason why it's a good idea to use these teardrops on a vertical hole is that once you make it perpendicular, it's a 45-degree overhang. So 45 degrees is very manageable for a printer, and then you won't have droopy holes. But again, depending on your print and like your dimensional requirements, you might have to print a circle. And if you do have to print a circle, you can use supports, right? But again, to reduce post-processing time and material, it's generally a good idea to try to design these things out. So I'm going to say like design things out like many times, and it's because you have the power to do that. So if you do it, it'll make my life easier or anyone who's printing your parts easier. Bridging is the next thing. So I talked about that person who sent me the Golden Gate Bridge. So don't do that. That's a very long bridge, and it can be more difficult for a printer to reproduce. So you can see I actually have a bridging test, but basically what the printer will do is usually it'll slow down. It'll like crank the fan speed up to its maximum, and then it'll try to cool down the filament as well as it can as it spans like 2 points, right? And usually as you create a longer and longer bridge, it becomes more and more difficult for the printer to reproduce. Again, my printer is tuned in fairly well, so it can bridge okay. But it's generally a good idea to avoid it. So I'll pass this around. You can see how shorter bridges look okay, but as they get longer, it starts to get a little ugly. So please avoid bridging. Obviously, there are places where you might have to bridge, and usually short bridges are fine, but please avoid long bridges. If I guess one way to avoid it is by adding like two features that kind of go up in a triangle instead of making it completely flat on the top. So again, creating like two 45-degree angles going up to the bridge. Maybe that could make your bridge shorter depending on your design. But again, keep this in mind when designing stuff. A lot of this is like very technical, so I won't like get mad at you if your prints aren't like super easy to print. But just like keep this stuff in mind. As you do it more, you'll kind of understand. Also, like please don't send me a sphere. In the last session, someone sent me a sphere to print, and if you think about a sphere, it is like it has a bunch of extreme overhangs at the bottom, and then it gets nice, right? So if you think about like again a tangent line going up as you go around this circle, the bottoms is at a 90-degree overhang and it progressively goes up to 0 degrees. So again, don't send me like round things on that print bottom up, right? You can have round things on the top, like right here. This curve is totally fine. It's totally manageable. But if you send me this to be printed like upside down, it'll become more difficult. And again, I can use supports, but that adds to printing time and material costs. So if you're making a lot of them, I'd recommend not doing that. The other thing to keep in mind is thermal expansion and tight tolerances. So if you have a machining background, a lot of people here like to measure things in like the thousandths of inches. So you're like measuring like portions of human hairs when machining something out of metal, usually because you're using a very rigid and very precise machine. And while 3D printers are great and they're relatively precise, they may not be as precise as you think. So when you design things, you might need to add a little bit of wiggle room into your parts to make sure that you get what you're after. So especially because 3D printing, at least FDM 3D printing, uses like heat to warm up the filament and deposit it. As the print cools down, it'll shrink a little bit, right? So all of these can throw off your tolerancing, and it's both very dependent on the printer and dependent on your design. So I like to give like tolerances of about 0.2 to 0.4 millimeters. So when you're designing like a hole, like let's say you want an M3 bolt to go through a hole, right? I'm not going to make that hole exactly 3 millimeters because when I do that, it's not going to fit. And then if it doesn't fit, I'm either going to need to like drill it out or like force the screw into its place, right? And I could easily avoid that. Again, because you're designing the part, I can easily avoid that by changing the size of the hole just slightly when designing things. So usually when I like do M3 screws and stuff like that, I like to do anywhere from like 0.2 to 0.3 millimeters on top of the 3 millimeters of the diameter. So if I want something that, like a bolt to go through a hole, I'll make like a 3 millimeter bolt will have like a 3.2 millimeter hole on the 3D printed part. So it'll fit nicely. Um, the other thing to consider is like elephant's foot. It's what we call like a little bit of extra squish at the bottom of a print. This has become a little bit less of an issue with like better printers, but it'll still happen sometimes. So basically what happens is when you print something, the first couple layers sometimes are a little bit squished into the print bed to make sure it adheres to the print bed and doesn't fall off when you're printing it. So when you do that, the layers might squish out a little bit, and if that like edge is important dimensionally, it may not fit into the part that you want it to interface with, right? So the way I suggest you combat this is by adding chamfers at the bottom of your prints. So again, it's a 45-degree overhang, so printers can reproduce it. And if you have a little bit of squish, because you removed some material in your model, the little bit of squish won't affect the outer surface of your part. Again, these are very minute details, and once you start 3D printing, it'll become more clear as to why these are important. So if these don't make sense completely, that's okay. You can also ask me about it because I'm happy to answer questions. But yeah, something that you can do is you can like test your printer to make sure like everything is good and tight. So like make sure your belts are nice and tight. Um, you know, as long as you tune your printer well, you can add less and less tolerance. But normally you're not going to be doing zero tolerance, if that makes sense. So yeah, this trident has been pretty accurate. I'd say like 0.2 to like 0.15 is like manageable. But again, depends on your model, depends what you're after. Yeah. Here's a good example of thermal expansion not being our friend. So you see here, this is a past project that someone made, and they made this Lego person, right? And you can see how we printed it, and the torso didn't fit onto the body, right? And it's probably because they didn't add tolerancing to the parts. So in Fusion, they will fly together, right? Because you're working in a virtual environment and you're not limited by tolerancing or anything like that, or gravity, right? So when you export the file and print it, and it prints it in the real world, not everything works out. So here, I'd say these two pin pieces were probably exactly the right size in Fusion, but if they made it a little bit smaller, then it probably would have fit in more nicely. So yeah, this is a good example of, making sure you have your tolerances and accounting for these different inconsistencies in manufacturing. For your homework, we have a quiz. Again, it's not very hard. It goes over a lot of stuff that I talked about today. We still have time, so feel free to take it now and I can answer your questions. It's like unlimited attempts, so don't like be scared at all. This is purely for your knowledge, just so you can keep all these things in mind when you're designing more stuff. Because if you print fast enough, you're gonna just be trying to build off of it. Cooling is something. Yeah. You can see like their cooling is like off the printer. It looks like a turbocharger. But that has like an insane cooling capacity. And a really long like melt zone, so you can melt water from it faster. I just actually just got my extended clock today. So I should be able to. Yeah, that one's insane. Also, for your slice profile, please as the element generic PTG. So sometimes it will change the time like slightly. If you forget, probably fine. Um, but you heard it now, so hopefully you. for like the size of your final project, I like to say please be reasonable because there's a lot of you and only one of you. So just keep your print size reasonable. The reason why I'm not really giving you numbers is because like some people like to print really specific long things. Those things feel like small and like volume should be things. Like if you print a really wide thing, it's gonna take more time. So yeah, just be reasonable. Like the three benchy is like a great size. But I have people training ugly stuff on the previous session. So yeah, as long as you like again make sure you keep what I said in mind today about the manufacturing stuff, because that really affects like how I think. Yeah. Also, if it's too big, then I would probably scale it down. And if it's smaller, then I might scale it up. But don't count on. I would prefer to do it by. I trust your judgment. So, the final project is due a week after the last session. So it'll be due like Tuesday. And hopefully I can get all your prints out before finals are over. I can't guarantee it, but I'll do my best. I think this should be able to print out. I think I'm about to print the finals for a second. I think but I also need to. Yeah, I'll just like tell you guys we got this. I'll get a box of notes. I'll just let you guys know.